All right, in this video, we're looking again at a lot of data, only this time the question is going to be a little bit different. We're going to have to actually interpolate, and we're going to have to find something from our data. To interpolate means to use our best fit line, or it means to use the data to find something else about it. Normally, interpolate means it's going to be something that's between your data. And what I mean by that is we're going to be using the number 39. 39 falls between 16 and 65. Right, so our smallest number is 16, our biggest number is 65, and 39 falls within them. Sometimes we'll also talk about I think it's extrapolate. Extrapolate? I think it's extrapolate. And that would be like if we had the number like 75, where it doesn't fall within that range. Right? So, but that doesn't really matter for us. I'm going to erase my blue lines here, and we're going to go ahead and read the problems and plug in. Again, just like last time, I'm going to do numbers 1 and 2, kind of trying to make sense of everything and understanding it. Numbers 3 and 4, I'm going to try to do it a little bit faster. So number 1, economists have found that the amount of corruption in a country is correlated to the production or productivity of that country. Productivity is measured by gross domestic product, or the GDP, per capita. Corruption is measured on a scale of 0 to 100, with 0 being highly corrupt and 100 being least corrupt. So we've got our data there, our corruption scores and our GDP. So we look over at our right paragraph, or our second paragraph. This can be modeled by the equation y equals 1250 times 1.05 to the x, where x is the corruption score and y is the GDP per capita in dollars. So we can see that this is a little bit of a curve there. We have our six data points listed, and they found a best fit curve. This is an exponential curve if we were to categorize it like that, and it has a positive correlation. What we really care about is the equation that they found here. Right? There's all kinds of data, but what's going to stick out to us is that. Now let's read our actual question. According to the model, what would be the GDP per capita of a country with a corruption score of 39? So let's read back up the second paragraph. We have y equals 1250 times 1.05 to the x, where x is the corruption score. So it tells us our corruption score is 39. So x equals 39. And what I'm going to do now is I'm just going to plug in, type it in my calculator, and see what I get. So y equals 1250 times 1.05 to the 39th. So whenever I type that in my calculator, I say 1250 times 1.05 caret, or the exponent button, and I get 8380 I'll say 94. And it says round to the nearest dollar. So this is going to be good grief, 8381. And we're talking about dollars. All right, all we did there was we used the equation they found, the best fit curve, and we plugged in the corruption score they wanted. And that's what we're going to do on all these, right? Don't make them more difficult than they need to be. There's lots of data there, and we're able to skim over a lot of it, right? If we had pretty well ignored all of this, we would be okay. So let's look back at number 2, or let's continue on to number 2. The number of times that a school has won the National College Basketball Tournament is related to the number of times that the school has participated in the tournament. Here is the data for several schools. All right, second paragraph, the relationship can be modeled by y equals, in that very long equation, where x is the number of appearances, and we know from last problem this is going to be important. X is the number of appearances in the tournament, and y is the number of championships. So we've got our little curve there. According to the model, you would expect a school with 8 appearances to have how many championships? Round your answer to the nearest whole. So the important thing is 8 appearances. Well, that's what the x is. So x equals 8. And I'm going to plug into y equals 0.0092. Then I'm going to plug in my 8 squared minus 0.246 and my 8 plus 0.938. And I grabbed that all from right here and I plugged in what my x was. All right, I'm going to take all that and I'm going to plug in. So I've got 0.0092 and then parenthesis 8, parenthesis squared, minus 0.246. And then I have times 8 plus 0.938. Okay, after I typed that in my calculator, I got negative 0.44, which doesn't really make sense, right? It doesn't really make sense for them to have a negative amount. But it says to round your answer to the nearest whole. Well, the nearest whole would be 0. So we'd say about 0, and what are we talking about? Championships. Now, the reason that we got a negative there is because they took the data and they plugged it into a model, right? They modeled the relationship. And whenever you model a relationship, you sometimes can be losing a little bit of the data. You can be losing some of the authenticity or the, I don't know about the correctness of the data. It can be very useful, but you also have to recognize that sometimes it pulls you away, right? If we were talking about a number farther out here, it would make a lot more sense. The model would make a lot more sense. But the answer here is 0. All right, so the first two I went through very slowly. I explained what I was doing. Number 3 and 4, I'm going to try to go through pretty quickly. So number 3, starting off, I'm going to ignore all this. I'm going to even ignore the graph. I'm going to look in here. I'm going to say, well, y equals this, where x is the year and y is the yield. I don't even know what they're talking about. It looks like they're talking about plants. I don't really care what they're talking about. I'm just trying to figure out the answer. According to the model, what was the crop yield in 1992? Well, x is going to be 1992. And then we're supposed to round to the nearest whole. So I'm going to plug in y equals 93.4 times 1992 minus 180,000. So on my calculator, I type in 93.4 times 1992 minus 180,000. And I got 6052.8. I'm supposed to round, so this is about 6053. And what are my units going to be? I look back up here. Y is the grain yield in kilograms per hectacre, and they actually have the nice little units there, so it's going to be kg-HA. There we are. Right. Big thing for standardized tests. Ignore the data you don't need. And after you take a couple of the PSAT or the SAT, you'll be able to do this a little bit faster. So number 4. Here's the value of, well, actually, no, I'm trying to do this fast. I'm going to ignore that. My equation is here. X is the number of years. Y is the number of dollars. I look down at my problem, or my actual question. According to the model, what is the value of an investment after 10 years? Well, X represents years. And now I just need to plug in. So Y is going to be 2410 times 1.15 to the 10th. So typing in my calculator, 2410 times 1.15 to the 10th, and I got 9749 we'll say 8. But it says to round to the nearest dollar, so this is really going to be 9750. And we're talking about dollars, so I put the dollar sign in front of it. All right, there's your last two. So again, you can go through these very quickly once you understand how the problem works. And that's part of why I'm doing this unit, so that you can see how these problems normally work. That way, whenever you get to the SAT, the PSAT, the ACT, all those standardized tests, you can learn to ignore some of the problem, right? It's a little bit of a skill learning to ignore the problem. Um, and it's a skill that you have to learn, so that's why I'm doing this. All right, there we are. Email me if you have questions.